Cool. You want to hear my last story?
I do want to hear your last story.
This one actually comes way from our buddy Mike in the chat.
Hey, yo.
He's Miroku Nightfang.
Shout out to Miroku Nightfang in the chat.
If anybody's ever played video games with him, you've probably won Trials of Osiris or a few games of Fortnite. He's pretty good.
Yeah.
But anyway, he sent me an article about gravitational lensing, and I thought it was pretty cool because we used gravitational lensing to see the farthest individual star we've ever seen, which is pretty cool.
That's pretty wild.
So let's kind of break that down for a second. So gravitational lensing. So I'm not saying. So when we're looking at something far away and we want to get a good look at it, we can look at things super far away to the things like 10 billion light years away when we're looking at something like a galaxy, which is billions of stars. Mm-hmm. But we've never been able to look at one star who's been like 9 or 10 billion light years away because it's one star. Mm-hmm. And the only time you would see one star is if it was a supernova. And when it does that, then it already blows up. But we've never been able to actually look at a star that far away and see what it was. But in this case, we were able to use gravitational lensing to see the star. Okay. And the way that works is that when there's a massive body, in this case, it was actually a galaxy cluster that passed, it was 5 billion light years away from us, and the star itself was 9 billion light years away. So we got to see the individual star 9 billion light years away because of a galaxy cluster 5 billion light years away. As that light was coming from the individual star from 9 billion light years away, it was bent around the intense mass of the galaxy cluster, and as that light is bent around, it's actually focused like a regular lens would do inside of something like a telescope.
I see.
So it's like a giant astronomical telescope, and these things actually change and move. Because the galaxy clusters are moving, you're not always going to see this intense, this magnification of the star. And so when they were observing this star, they saw a huge uptick of the luminosity of the star. It looked super, super, super bright. But when they looked at it, it didn't get extremely hot. So it wasn't like a supernova event, so they looked at it more closely, and they saw that it was this magnification effect of the gravity from that cluster of galaxies, focusing the light so that we could see that individual star super, super far away.
I see. Okay. So let me get this
Interject.
straight. Let me get this straight.
I just spit a lot out.
I like that. I like that. So if I can summarize, let's just pretend, right? I'm the observer. I'm on Earth with the telescope trying to look at the faraway star, right? Mm-hmm. That's me. You're the star. Let's just say,
okay,
for hypothetical sake, you're the star that's really, really far away. What was it? 9
billion light
years away. Universe is only 13 and change billion light years old. Across, so this is very far
to see an individual star. Yeah.
So now we're gonna say that this beer can
is the galaxy
cluster, and it's fucking massive, right? There's
tons
so many
multiple
stars.
Galaxies.
Holy shit! And it's between you and me. It's between the line of sight.
So as my light is going around this, it actually focuses it the same way a regular lens would focus light, bring all the light together, and it actually magnifies it. And in this case, they said it magnified it something around, I believe, 600 times.
Wow. Okay.
So it made it 600 times bigger.
Right. So the light is actually attracted to the gravity, comes back around, right, from you to my eye.
Yeah, so someone who's not that familiar with astronomy, it's kind of weird to think about light being bent. Mm-hmm. Because light is light. It kind of just, when you think about it, it kind of just moves.
Yeah.
But when you have that much mass, such as clusters of galaxies, even light itself is going to be influenced by the gravity.
Right. So now this thing kind of gets magnified in a sense.
Literally magnified because that light gets focused as it gets bent around.
And then the appeal of this is that the star itself is not undergoing supernova, so it's not exploding.
It's not getting super hot or bright. Right. We're just able to observe a star that's that far away.
It's just a star.
So I can tell you more about Icarus as well, the star.
Its name is
They
Icarus?
called it Icarus
Swag.
because of, based off Greek mythology, when you fly too close to the sun, the Greek story. That your wings burn up when you get too close to the sun. Mm-hmm. So Tom is the star. Fana says thank you. Have you seen that NASA discovered a second moon, but that was aged only like 3 years ago? I'm not sure you're talking about, little spud. Evil Panda says gravity, what a force. But yeah, anyway. So Icarus, that's why it's called that. A few things about it. It's a blue supergiant. So here's the thing. It's already way more massive than our sun, up to hundreds of thousands of times more luminous, but still we would not be able to see it because it's 9 billion light years away. So it really is the magnification effect of the gravitational lensing that's letting us view this star, but it is a really big star.
Mm-hmm.
So that's the kind of star that we were seeing. And then the last point that I wanted to talk about is that actually they were testing something about dark energy, dark matter. They wanted to test the theory of primordial black holes being the cause for dark matter.
Okay.
So a primordial black hole is a black hole that's formed very early in the early universe and over time has enough time to collect mass and be the super center of mass and matter.
That's what we call an OG.
An OG black hole.
A lot
Been
of people
around from
use
the
term
beginning.
Primordial. I like to
I
use
could
the term
call
OG.
it OG.
Okay.
Exactly. So they actually tried to test this theory by studying the star, and they found out that from the way they viewed this star that it doesn't look like there are primordial black holes in the galaxy that's bending the light. So they were looking at the mass of that galaxy to see how much the light bent, and it didn't really match what you would expect if there were these massive black holes with this much matter in them.
Gotcha.
So kind of checked off,
Yeah.
slashed off that theory of
That's
dark
cool.
energy as well.
We can tell something about the galaxy cluster
itself as well,
and its
by how
mass.
much it bends the light.
Right. Got it.
And those are my stories.
And that's the fucking news, baby. Let's fucking go. All right, Tom.